Good morning, class. As you know, today is the day we call our Career Day. The purpose of this day is to help you to decide your life's careers. We have invited secretaries, engineers, doctors, nurses, and businessmen to come here today to talk with you. Each of you who has asked for a conference with one of our visitors has been scheduled for an interview in a specific room in this building. I hope that you will find these interviews both interesting and valuable. Several of you have your appointments for this first period. Those of you who do may go now. Oh, Joe, you're to see Mr. Kelly, aren't you? His room has been changed to number 39.
Number 39? Thank you.
Mm-hmm.
Mr. Kelly?
Yes, I'm Paul Kelly. What's your name?
I'm Joe Williams.
Joe, I'm very glad to know you. Won't you sit down?
Thank you.
Tell me, Joe, what can I do for you?
I'd like to talk to you about engineering.
Joe, engineers practice the art and science by which the properties of nature and the sources of power in nature are made useful to man.
Yes, Mr. Kelly, I know that. I want to know what it is that an engineer does.
Now, that depends, Joe. Some engineers do research, some engineers do development. Then there's design, construction, production, operation, sales, and maintenance. You find engineers doing these things with power companies, telephone companies, electronic manufacturers, and with companies that make steel, jet aircraft, bridges, machines, highways, ships, and medical supplies. There are engineers that work at desks with numbers. Some write reports and manuals. And some engineers are managers of other men. In fact, Joe, an engineer is now president of the largest corporation in the world. It takes all kinds of engineers: civil, electrical, mechanical, aeronautical, and many, many others. Does that help you, Joe?
No, Mr. Kelly. That's what everybody tells me about engineering. I can't explain exactly. You see, I'm thinking about being an engineer, and I want to know just what an engineer does when he's working.
That was a kind of general answer, wasn't it, Joe? Let's look at engineering in a different way. Suppose we look at just one engineer. Take me, for instance. How did I become an engineer, and what do I do at my work? Would that help you, Joe?
Yes, sir.
Joe, I'm an electrical engineer. Now, though I'm an electrical engineer, Joe, all of us engineers have a lot in common. So what I tell you about my education and experience is a lot like that of other engineers. You know, one of the smartest things I ever did was to go to an engineering college. Today, you have to have a degree from an accredited engineering college if you expect to get anywhere in the profession. As I look back now, I realize that I received 3 important things out of college. 3 things an engineer must have. First, a good technical education in engineering. Secondly, training and practice in speaking and writing effectively. And finally, well, Joe, let's call it social and cultural development. Joe, the first 2 years at any college of engineering, all engineering students take the same basic stuff: math, physics, chemistry. These are the backbone of engineering. Some of the experiments in physics, I suppose I'll always remember. And the same can be said about the laboratory demonstrations in chemistry. Yet, some of my biggest thrills came from the new ideas I received in college. There's beauty and power in mathematical analysis, and there's something awe-inspiring in the simplicity of many of nature's fundamental laws. The last 2 years, you get into the more typical engineering courses. I can remember as a student in one lab making circuit test after circuit test.
Okay, test number 19.
Effective value harmonic current, 1 8/10 amperes.
Oscillator frequency adjusted to 0 beat. Maximum indication, 15.
Waveform's okay. There's no distortion.
Okay, test 20.
Then there were those transmission problems.
Well, I see we're about done. Kelly, suppose you explain how we evaluate alpha for the condition you have.
Well, the first thing I did was to change this
Kelly,
equation.
to the class, please.
Oh, I'm sorry, sir. Yes. The first thing I did was to change this equation. You'll notice I've kept R in the equation. However, I've dropped G out of the equation. Then, factoring that equation out, I secured this result. Then, using Taylor's series, I expanded this expression, dropping out the higher order terms. Then, substituting alpha plus J beta for gamma on this side of the equation and multiplying and rearranging on this side of the equation, I came out with this result. Therefore, alpha equals R over 2 times the square root of L over C, or more simply, R over 2 Z sub 0. Now, knowing R, L, and C, I can then calculate Z sub 0 and alpha.
Very good, Mr. Kelly. Are there any questions?
I'll never forget that day in the dynamo lab when our squad was unprepared.
What we got to do today?
A study of the wound rotor induction machine. Hey, you had a chance to figure this problem out yet?
Oh, I thought you and Kelly'd have it done.
Hey, Kelly, how about it? Are you our fair-haired boy?
Gene, today you better call me Baldy. You mean you haven't got it done either?
No.
Guys, we got to do something. Look, we've got 3 hours. What do you say we just get this by the cut-and-try method?
Well, I think I can remember how to hook up an induction motor. Hey, Kelly, why don't you run around and see if you can scrounge up some instruments?
Okay.
Let's get started.
All right.
Okay.
Number 6.
Okay. You guys about ready?
Just a shake. You want to check? Yep. Yeah, I think so.
All set. Throw the breaker, Gene.
No, wait. Hold it. Turn it off. Something the matter back here, I think.
It might be one of these, too.
Well, I think it's this one here.
You fellas are obviously unprepared today. Why don't you clean up this mess, go in the conference room, study your problem, make some calculations, get your instruments that you need, take your data. Cut out this aimless guesswork. Use your heads.
Yes, sir.
Well, you all set?
Yep, I think so.
Okay, fellas, here it goes.
Hey, now there we go.
We figured the first load to be about 5.2 pounds, didn't we?
5.2, that's right. Okay.
Let's try it.
The second thing I got out of college was training and practice in expressing my ideas in writing and in speaking. Don't slide over that English you're getting in high school now, Joe. It's mighty important. Professor Yeager really made it rough on me in report writing.
Not bad report.
Thank you, sir. D. Yes, Mr. Kelly. It's unsatisfactory. But the facts are all there. I checked every one of them twice.
Let's admit the facts are there. But the report itself, it's dull, it's uninteresting.
Look, Mr. Yeager, I'm a facts man. I'm an engineer. I have no desire in the world to be an author.
An engineer must have facts. But in addition, those facts must be presented convincingly. Now remember, this report was for management. Let's take a look. Now, these illustrations. Who but an engineer would understand that? But in addition, it's really your sentence structure that causes your report to be dull and hard to understand. Now, I know you can do better because your oral reports are quite good. Suppose you come in this afternoon and we'll compare your written work and your oral work and see if you can get a better idea of what I'd like to have you do.
Well,
sir.
Thank you. Well, after our conference, I rewrote that paper. But I never fully appreciated Yeager's insistence on clear presentation until after I'd been working for a while as an engineer. The third thing college did for me, we'll call it social and cultural development. I took a few good non-technical courses. I participated in some wonderful extracurricular activities. I developed a liking for good plays and music. Then there were stimulating associations with fellows who were students of art and literature. You're thrilled by the pageantry and excitement of college athletic events. College also gave me a chance for some pleasant social life. That's important, and in addition, going to dances is fun. During my senior year, I began thinking about a job. Representatives from various companies came to the campus to interview us seniors. You know, making up your mind about the type of work you want to do is mighty important. Then, after you decide on that type of work, there's a problem of getting that kind of job. Fortunately for me, engineers were in demand when I graduated, so I had several job offers that were pretty good. Then I decided on the company I wanted to work for.
But I don't know what kind of engineering I want or like. Everything is so big and, well, kind of broad.
That's natural enough, Joe. You don't know enough to make up your mind now. In fact, you don't have to. I didn't decide to become an electrical engineer until I was a sophomore. Later, as a senior, my faculty advisor told me that it didn't make too much difference what company I chose to work for. What's really important is, does that company offer you challenging work and an opportunity to prove yourself a good engineer? Finally, graduation day arrived. It was thrilling to be a part of a great academic pageant. And believe me, Joe, after working so long and hard, that diploma really meant a lot to me. After graduation, I went to work on my first job. And Joe, I'm still with the same company, although I've had many assignments and some promotions since I started. Here's what my company did to get me acquainted with their operation. And this procedure isn't unique. A number of companies use the same procedure with their young engineers. For a while, I worked in the inspection department. We were responsible for making sure the equipment the company manufactured was of high, uniform quality. This was done through a series of tests like those I performed in college. After working a year in the inspection department, I was transferred to the engineering department where I was just one of several engineers. Now I had a better chance to show my ability, for I was given some design problems. I found the older, more experienced engineers stimulating and helpful. After several years in the engineering department, I was transferred to sales. At the start, both you and the chief felt that a radio system should be installed. Well, it can be, and it'll operate quite satisfactorily. However, I'm recommending a paging system. It'll save you money to begin with and require less maintenance. Now, let me take you through the steps in our study of your communication problem, which lead directly to this solution. In every case, the work I had to do was a continuation of a course or an experience I had in college. Today, I'm a system design engineer. I take the communication problems of a customer, which have been referred to me by our sales department, and coordinate the design and development of the equipment required. Then I follow the equipment through its manufacture and installation. Here's an example. A while back, a big electrical power company asked us, as well as several other companies, to submit plans for installing a mobile radio system that would meet their special requirements. Remember, Joe, we were just one of several companies competing for this job. That's usually the way it is. And it's this kind of competition that really keeps you on your toes. We had to work fast on this job, and it had to be designed at the lowest possible cost, still allowing a reasonable profit for my company.
Did you get the contract, Mr. Kelly?
Wait a minute, Joe, not so fast. You're going to spoil my story. The first thing we did was to get all available facts. Getting the facts meant going over much of the power company's territory and facilities. I had to find out their methods of truck dispatching, and the area to be covered by the radio system. I found this power company served an area which was like a long rectangle. This presented a problem, for the simplest radio antennas broadcast a circular coverage. To send a strong signal to all parts of this area meant that we had to design a special antenna. The power company wanted another unusual feature, a signaling device to get the attention of a driver, even when he was some distance from his truck. I visited the electric power company's generating plant and consulted with their engineers. I had to know the company's communication problem if I was to design a radio system which would fit their specific needs. After collecting all of that information from the power company, I wrote down all the questions which had to be answered before the design could be completed. Some answers I could get for myself, but I had to do some digging in reference books and journals. I found I had to have help with the design of the antenna, too. So I called our development research department for aid. In our research department, another engineer tackled the problem of the electrical design of the antenna. This was first done using miniature elements mounted on a circular copper table. The signal strength and directional characteristics of the different designs could thus be measured in the laboratory. Finally, a model was built and tested. The research engineers had really helped me, for the antenna gave a much stronger signal than I had thought possible. At the same time, other engineers were working on the mobile radio equipment. Remember, we had to build a signaling device for the truck driver. Well, we devised a means by which we could blow a truck's horn by radio whenever the driver was out of the truck. Meanwhile, we had to be certain that we hadn't forgotten a single expense. Just think what poor engineering it would have been to have set our price, won the contract, and then found out we'd forgotten some important cost. Then, in place of making a profit, the company would have lost money. That's poor business as well as poor engineering. Finally, we were ready for our final conference with the power company officials. We knew we had a good plan, but we had to convince the customer. Gentlemen, let me summarize my company's proposal. You have a territory that is long and narrow. Now, we know that our equipment will effectively cover that area using only one transmitter and 5 repeater stations. These stations will maintain contact with any of your service trucks, day or night, in any kind of weather, in any part of your territory. The reliability of the system is assured by 2 features. One, the provision for field strength margin. The other, automatic switching of standby equipment. We have met every communication requirement specified by your company. And in addition, our thoroughly tested equipment will give you trouble-free, low-maintenance cost service. Gentlemen, if you wish, we can begin installation immediately and have the system completed within 3 months.
What about the contract, Mr. Kelly? Did you get it?
Yes, Joe, we did.
I bet you went on a swell vacation after that contract came in.
No, Joe, nothing of the kind. Now that we had that contract, I really had to get to work. I had to confer with the production engineers and get a schedule for delivery of the equipment. Everything was progressing nicely when one of our parts suppliers had a fire and couldn't furnish some special relays. That threatened to upset the whole construction timetable. But we had an experimental relay unit about ready for production. It was tried and it worked fine. So, by advancing the production date for these relays, we got back on schedule, but it was close. While all that was going on, I had to write the operation and maintenance manual. More than once, I remembered how tough Professor Yeager was. I knew what had to go into those manuals, and I knew I could write clear instructions. Those manuals were going to be as good as the equipment. While I was finishing the manuals, the base station had been erected and put into test operation. This enabled other engineers to get into the field and make tests of the equipment under operating conditions. The equipment met all the specifications. Remember the truck driver signaling device? Well, this is how it works. Suppose the workman is away from his truck, and the power supervisor wishes to call that specific truck. On the radio control panel, he punches that truck's number. The driver hears the horn and starts for his truck. The supervisor gets no answer, so he calls that truck again.
Six, 791. 6791.
This is a field test.
Hey, this is going to be the nuts.
At that time, the signaling device we used was new. Now the system's found quite generally.
Gee, Mr. Kelly, engineering is swell, isn't it?
Not all jobs are as exciting as the one I've told you about, Joe. But I hope what I've told you gives you a good idea of how an engineer works. Other engineers and I have found great satisfaction in having a share in building America and helping make it strong and great. These joys of achievement are felt by all engineers who design and build things, whether it be factories, highways, ships, airplanes, or machines for making things. Engineers, in creating these things, applied the same principles you saw at work. You must first learn the requirements and be able to visualize the needs of people. Only then can you set about the enormously difficult and thrilling task of creating things and services which never existed before. These, Joe, are what an engineer does. If you haven't the will to spend the untold hours of study, and usually a lot of worry to gain these satisfactions out of creating and building, then you're not for engineering. But if you visualize yourself as one of these very special builders of America's future, if you have a keen desire to have a part in bettering the standards of living, then you should become an engineer. Now, Joe, do you think you should be an engineer?